Hello dear students, welcome back to the class 9. So in the last class we have completed with the exercise number 2.2. In this we have studied we studied the concept of polynomial in one variable and polynomials in two variables, and also how to equate that zero, and also we have studied the zeros of polynomial. So zeros of polynomials we have seen. So if it is equals to 0, then it is the zeros of the polynomial of that p of x. If it is not equals, then it is not a zero of the polynomial p of x. Okay, so this concept we have studied in the previous video, and also we have solved some of the example of exercise number 2.2. Okay, so in this concept, in this video you are going to learn that is very important theorem, that is remainder theorem. So this is the statement of remainder theorem. In the remainder theorem, the statement says let p of x be any polynomial of degree greater than or equals to 1, and let a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. Okay, so dear students, let p of x be any polynomial of degree greater than or equals to 1, and let a be any real number if p of x is divided by the linear polynomial x minus a, then the remainder is p of a. So here the question says let p of x be polynomial of degree greater than or equals to 1, and a be any real number, means you already see in the definition of real number, the combination of rational and irrational numbers is called real number. So a be any real number, and the first statement says p of x is greater than or equals to 1. If p of x is divided by the linear polynomial, x minus a, you know that linear polynomials means the degree of the polynomial is 1 here. So p of x is divided by x minus a. Okay, so then the remainder is p of a. The remainder is, we are getting this as p of a. So this is the question, means what the question says, dear students, if x minus a, when you divide with p of x, you are getting the quotient as q of x, and the answer you are getting the remainder as r. Okay, so x minus a is equals to p of x into q of x whole divided by r. Okay, so x minus a into p of x is equals to q of x whole divided by r. So this is the question, this is the remainder, means what you have to do, we have to x minus a, this x minus a we have to equate to 0, and x is equals to, we have to put the value as a. It is x minus a is equals to 0, and x is equals to, we will get the answer as a. Means what the remainder theorem says also, that is dividend is equals to divisor. Dividend is equals to divisor into quotient plus remainder So dividend is equals to divisor into quotient plus remainder, means here dividend is p of x, divisor is x minus a, next quotient is q of x, plus remainder is your r, okay. So this is your r you are getting. So here, dear students, you have to put x minus a is equals to a, that is x minus a we are equated to equals to 0, means x is equals to a, you have to put in this given equation. Put here x is equals to a. So I put this x is equals to a in the given equation, that is I write the equation here, that is p of x is equals to, you have, that is x minus a into q of x plus of r. So this is your equation. So this is your equation. Here you have to put, that is x is equals to a. If you put x is equals to a, you are getting that is p of a. P of a is equals to, that is a minus of a into q of a plus of r. Okay, so a minus a, which is equals to 0, that is 0 into q of a, which is plus of r. So anything into 0 is 0. So your answer is p of a is equals to r. So p of a is equals to r. So this is your reminder theorem. Okay, so whenever just you have to equate x minus a is equals to 0. If I extract x minus a is equals to 0, you are getting the answer as x is equals to a. If you are getting x is equals to a means, you have to put in this equation and you have to solve. That is p of x is equals to x minus a into q of x plus of r. That is put x is equals to a. If you put, you are getting the answer as p of a is equals to r, as your statement says. So this is the proof of remainder theorem. So please go through this and note down this proof and note down the statement. By solving the example, we will come to know some of the examples we are going to solve on the remainder theorem. So dear students, I will take one example. So is it satisfying with the remainder theorem? So see, I will check this by seeing the polynomials. So there are two methods for finding the value for the remainder theorem. So that is example 1, by factorization method, or you can use by the remainder theorem to find the value of x. So I will use the first method, that is factorization method. That is x cube minus of 3x square minus of x plus 5. I divide this with x plus 1. So this is which I am doing, this is factorization of polynomials. So there are two methods, one is factorization polynomial, or one more method we can substitute by direct using the remainder theorem. So see here, I am solving by factorization method. So this is x cube minus of 3x square minus of x plus 5. So I want now quotient. So I need the quotient, means first you have to take the first term, that is x cube. You have to take the first term as x cube, then you have to divide with x. So see here, you know that is a raised to m divided by a raised to n. You already learned in a number system. So only I told the exponents concept, that is a raised to m minus of n. Similarly, so this is x, this is m is 3 and your x raised to 1 is n. So x of 3x raised to 3 minus 1, which is equals to 2. So this is x square, means with the x square only you have to divide the quotient now. So see here, so I use the x square concept, that is x square into x is, you are having this as x cube. Next x square into 1 is, that is plus of x square. Okay, so now you have to interchange the signs. Now this is plus, this will becomes as minus, and this is plus, this will become as minus. Plus minus, this will get cancelled. So remaining is 3x square and x square. So 3x square plus x square you are having as 4x square. So this is minus 4x square. Okay, next this you have to take this down, it is minus x, you have to take this down, and you have to choose now one more term, that is minus 4x square. I need to divide with ex. So if you divide this, you are getting as minus 4x. So because in this, why? Because x square means x into x, and it is whole divided by x. So 1 get cancelled. So remaining is only x, that is 4 into x, that is minus of 4 into x. So see here, minus 4x you have to take the quotient, that is minus of 4x. Minus 4x into x is minus 4x square. Okay, then minus 4x into 1 is minus of 4x. So again it is plus, this is minus. So again cancel this, again we are writing this as minus of 5x. Is it? So this is plus now, minus becomes plus. So this is become 4 minus of 1, which is equals to, you are getting this as 3x. So now it is 3x. Now again you need to one more term that is remaining, that is you have to take plus 5. So now what you have to do, you have to multiply, that is plus of 3. So plus 3 if you take, that is why I have taken plus 3, because 3x by 3, 3x by x is x gets cancelled, so remaining is 3. So that is for 3 into x is again 3x, again 3 into 1 which is equals to plus of 3. So again this is plus, plus will becomes minus, this is plus, plus will become as minus. So this will get cancelled, so 5 minus 3 which is equals to 2. So this is by factorization method. You got the remainder as 2. The quotient is x square minus 4x plus 3 and the divisor is x plus 1. Now see, just use the remainder theorem and verify the remainder theorem also. So see here it is x plus 1. X plus 1 just equate to 0. If I equate to 0 means you are getting as x is equals to minus 1. So you are getting x plus 1 is equals to 0, then you are getting x is equals to minus 1. Then just to substitute in this expression, that is I substitute, that is p of x. First I write the expression p of x is equals to x cube minus of 3x square minus of x plus 5. This is your polynomial expression. Just I substitute, this is p of minus 1. If I substitute p of minus 1, that is this is minus 1 whole cube, this is minus 3, that is minus 1 whole square, next minus of minus 1 plus of 5. Okay, so dear students, so this here, this is number is odd. Whenever the number is odd, you have to choose this as negative, that is minus 1. How it is minus 1? So see here, minus 1 is multiplied 3 times, that is minus 1 into minus 1 into minus 1. So 1 into 1 into 1 which is equals to 1. Minus into minus is plus, plus into minus is minus. So this is minus 1. So this will write, I will write this as minus 1. Next one, minus 3 as it is. This is minus 1. Minus 1 if I do this, minus 1 whole square is minus 1 into minus 1 which is equals to 1 into 1 is 1. Minus into minus is plus. So it is 1. So 3 into 1 is, that is minus 3 plus 1 which is equals to minus 3. Then this is minus into minus is plus 1 plus of 5. So now values you are getting this as minus 1, minus 3 plus 1 plus 5. So now see, this is minus 1, this is plus 1. So cancel this minus 1 and plus 1. Remaining is minus 3 plus of 5. So 5 minus 3 which is equals to 2. By seeing the greater number sign, we keep the number is positive. So 5 minus 3 which is equals to 2. So by using the remainder theorem, if we equate to 0 and if I substitute at x equal to minus 1 in the given expression, x cube minus 3x square minus x plus 5, we are getting the answer as 2. Similarly, if I use the factorization method also, I am getting the remainder as 2. So you can use whichever method you want. So you can use the remainder method theorem, or you can use the factorization of polynomials. So these are the two concepts, and this is the theorem of the remainder theorem. So please note down and go through these problems and solve these problems and note down in your notebook.